While the National Electrical Code, or NEC, doesn't explicitly state a specific distance requirement for protecting personnel near open electrical panels and gear, several sections address safety considerations in such environments. Section 110.16 of the NEC mandates that electrical equipment be installed to minimize harm to personnel. This implies a need for adequate spacing to prevent accidental contact or exposure to electrical hazards. Section 110.26 focuses on guarding electrical equipment to prevent accidental contact. This section highlights the importance of barriers, enclosures, or other means to protect individuals from unintentional interaction with energized parts. When working on or near energized electrical equipment, additional precautions are necessary. Section 110.34 requires guarding energized equipment against accidental contact by unqualified persons. This emphasizes the need for restricted access and proper training for those working in proximity to live electrical components. NEC Section 110.36 stipulates that sufficient working space must be provided around energized electrical equipment to ensure safe work practices. This working space allows personnel to perform tasks without undue risk of electrical shock or injury. It is important to consider several factors when determining the appropriate distance for personnel protection near electrical panels and gear. These factors include the voltage of the equipment, the type of work being performed, and the presence of other hazards. Higher voltage equipment generally requires greater clearance distances due to the increased risk of arc flash and electrical shock. The type of work being performed also influences the required distance. Tasks involving manipulation of tools or equipment near energized parts necessitate more space to prevent accidental contact. The presence of other hazards, such as slippery surfaces or obstructions, may further increase the required distance. Ultimately, the responsibility for determining the appropriate distance rests with the employer. The employer must assess the specific work environment and implement safety measures to protect personnel. This assessment should consider the general requirements of the NEC, as well as any specific requirements applicable to the work being performed. Employers should consult relevant industry standards and best practices to ensure a comprehensive safety plan. Consulting with a qualified electrical safety professional is also recommended to ensure compliance with applicable regulations. Furthermore, employers should provide adequate training to personnel working near electrical equipment. This training should cover topics such as electrical hazards, safe work practices, and the use of personal protective equipment, or PPE. Regular safety audits and inspections should be conducted to identify and address potential hazards. Maintaining a safe work environment requires ongoing vigilance and a commitment to continuous improvement. It's important to understand that while the NEC provides a framework for electrical safety, it's not a substitute for sound engineering judgment and practical experience. Each work environment is unique, and the specific safety measures required may vary depending on the circumstances. Firstly, consider the voltage levels of the electrical equipment. Higher voltage levels necessitate greater clearance distances to mitigate the risk of arc flash and electrical shock. Secondly, assess the type of work being performed in the area. Tasks involving manipulation of tools or equipment near energized parts require more space to prevent accidental contact. Thirdly, evaluate the presence of any obstructions or hazards in the work area. Obstructions can impede movement and increase the risk of accidental contact with the electrical equipment. Fourthly, ensure that adequate lighting is provided in the work area. Proper lighting enhances visibility and reduces the likelihood of accidents. Fifthly, implement appropriate barriers or enclosures to restrict access to energized electrical equipment. Barriers can prevent unqualified personnel from entering the area and coming into contact with hazardous parts. Sixthly, provide clear and conspicuous warning signs to alert personnel to the presence of electrical hazards. Warning signs should be placed in strategic locations to maximize their visibility. Seventhly, enforce the use of personal protective equipment, or PPE, such as gloves, safety glasses, and arc-rated clothing. PPE provides an additional layer of protection against electrical hazards. Eighthly, establish and enforce safe work practices, such as energizing equipment before performing maintenance or repairs. De-energizing equipment eliminates the risk of electrical shock or arc flash. Ninthly, provide regular training to personnel on electrical safety and safe work practices. Training ensures that personnel are aware of the hazards and know how to protect themselves. Tenthly, conduct regular safety audits and inspections to identify and address potential hazards. Audits and inspections help to maintain a safe work environment and prevent accidents. The NEC provides specific requirements for working space around electrical equipment in Section 110.26. This section outlines the minimum clearances required in front of electrical equipment based on voltage levels and specific conditions. Table 110.26a provides minimum clear distances for nominal voltages to ground of 0 to 150 volts, 151 to 600 volts, and 601 to 2500 volts. The required distances vary depending on whether there are exposed live parts on one or both sides of the working space. Condition 1 applies when there are exposed live parts on one side of the working space and no live or grounded parts on the other side of the working space. Condition 2 applies when there are exposed live parts on one side of the working space and grounded parts on the other side of the working space. Condition 3 applies when there are exposed live parts on both sides of the working space. It's important to consult Table 110.26a to determine the appropriate working space clearances for specific voltage levels and conditions. In addition to the minimum clearances specified in Table 110.26a, additional working space may be required based on the specific equipment and installation. Section 110.26a addresses working space for equipment operating at 600 volts, nominal or less. This section requires that the working space be sufficient to permit safe operation and maintenance of the equipment. The depth of the working space must be at least 3 feet for equipment operating at 150 volts or less to ground. The depth of the working space must be at least 3.5 feet for equipment operating at 151 to 600 volts to ground. The width of the working space must be at least 30 inches or the width of the equipment, whichever is greater. The height of the working space must be at least 6.5 feet or the height of the equipment, whichever is greater. Section 110.26 addresses working space for equipment operating at over 600 volts, nominal. This section requires that the working space be sufficient to permit safe operation and maintenance of the equipment. The depth of the working space must be at least 4 feet for equipment operating at 601 to 2500 volts. The depth of the working space must be at least 5 feet for equipment operating at 2501 to 9000 volts. The depth of the working space must be at least 6 feet for equipment operating at 9001 to 25000 volts. The width of the working space must be at least 3 feet. The height of the working space must be at least 7 feet. It is important to note that these are minimum requirements, and additional working space may be necessary based on the specific equipment and installation. The NEC also addresses illumination requirements for working spaces around electrical equipment in Section 110.26d. This section requires that sufficient illumination be provided to permit safe operation and maintenance of the equipment. The illumination level must be at least 10 candles, or 107 lux, measured at the working surface. Adequate illumination helps to reduce the risk of accidents and injuries. In addition to the NEC requirements, OSHA, or the Occupational Safety and Health Administration, also has regulations pertaining to electrical safety in the workplace. OSHA regulations require employers to provide a safe working environment for their employees, including protection from electrical hazards. OSHA standards cover a wide range of electrical safety topics, including working space around electrical equipment, guarding of live parts, and the use of personal protective equipment. Employers must comply with both NEC and OSHA regulations to ensure a safe working environment for their employees. It is important to stay up to date on the latest revisions of the NEC and OSHA regulations to ensure compliance. Both the NEC and OSHA are regularly updated to reflect changes in technology and best practices. Staying informed about these changes is essential for maintaining a safe and compliant workplace. When evaluating the safety of a work area near electrical panels, consider the potential for arc flash hazards. Arc flash is a dangerous electrical phenomenon that can occur when a short circuit creates an explosive release of energy. Arc flash events can cause severe burns, injuries, and even fatalities. Conducting an arc flash hazard analysis is crucial for determining the potential risks and implementing appropriate safety measures. An arc flash hazard analysis involves calculating the incident energy levels at various locations near electrical equipment. The incident energy level is a measure of the amount of heat energy that a worker could be exposed to during an arc flash event. Based on the incident energy levels, appropriate personal protective equipment, or PPE, can be selected to protect workers from the hazards of arc flash. PPE for arc flash protection typically includes arc-rated clothing, gloves, and face shields. Arc-rated clothing is designed to resist ignition and prevent burns from exposure to arc flash energy. Gloves provide insulation and protection against electrical shock. Face shields protect the face and eyes from burns and flying debris. In addition to PPE, other safety measures can be implemented to reduce the risk of arc flash. These measures include installing arc flash relays, using remote racking devices, and implementing lockout/tagout procedures. Arc flash relays can quickly detect and interrupt arc flash events, minimizing the amount of energy released. Remote racking devices allow workers to operate circuit breakers and other equipment from a safe distance, reducing the risk of exposure to arc flash. Lockout/tagout procedures ensure that equipment is de-energized and properly tagged before any maintenance or repair work is performed. Maintaining a safe work environment around electrical panels and gear requires a comprehensive approach that includes compliance with NEC and OSHA regulations, implementation of appropriate safety measures, and ongoing training and education. By taking these steps, employers can protect their employees from the hazards of electricity and create a safe and productive workplace. Remember that electrical safety is a shared responsibility. Everyone in the workplace has a role to play in preventing accidents and injuries. By working together and following established safety procedures, we can create a culture of safety that protects everyone. When in doubt, always consult with a qualified electrical professional for guidance and assistance. Electrical work can be dangerous, and it's important to have the knowledge and expertise to perform it safely. Do not attempt to perform electrical work unless you're properly trained and qualified. Electricity is a powerful force, and it must be treated with respect.